All right, hi everyone. Today what we're doing is we're going to plug in limits in algebraic functions, and that's looking at polynomials and rationals. You only have one IXL today on this, and which is just plugging it in. Now we're not dealing with weird cases. We're just dealing with cases that actually work. Let me ask you, what does this graph look like? Y is equal to 3x plus 2. What does that graph look like? This is the shape of a regular line, I hope you can realize. So if it's y equals mx plus b, we know that b is 2, 1, 2, put a dot, and the slope is 3, 1, 2, 3. Move it over, and this is what the graph looks like. Are there any weird things going on with us, like a simple line graph? Do we ever shoot off to, do we have a vertical asymptote? Are there any numbers we can't plug in? Do we have any holes in it? And the answer is no. This line, this graph is what it is. And so if I start asking you questions like, what's the limit as x approaches 2 of 3x plus 2? What if I ask you what's the limit as x approaches 0 of 3x plus 2? These questions are actually oftentimes 99% of all the limits in the world are what you expected. If I say as x approaches 2, well, just what does it look like at 2? Plug in 2. 3 times 2 plus 2 is 6 plus 2 is 8. The limit is 8. It looks like 8. When x is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. The graph looks like it should be 8. Yeah, and the graph is 8. What does the graph look like as we approach 0? Well, just plug in 3 times 0 plus 2, that is 2. And on the left side and the right side, at 0, the y value is 2. Oops, I shouldn't use a hollow one. It is 2. This is 2. So we use this limits to describe what would it look like. Great, we know what it looks like now. Now, can I still use infinity? Sure. What's the limit as x approaches infinity of 3x plus 2? Now, I want you to understand this question. What does the y value look like if x got bigger and bigger and bigger? What happens to the y value? Does it come back down to 0? Does it go down to negative infinity? Well, looking at a very basic line, it looks like it's going to shoot off to infinity, go forever up. Now, what if I don't want to draw this graph? Let me ask you if I really did plug in infinity to the problem. 3 times infinity, does that make any sense? Not really. But you would agree if 3 times infinity is just a really big number like infinity. And what's infinity plus 2? Still infinity. And you can't really plug in infinity. It doesn't really make sense because infinity is a number, but we can get that generality, that idea of 3 times a super large number that never ends is a super large number that never ends. What if I add 2 to it? Ooh, it's still a super large number. Now, what if I say limit as x approaches negative infinity, okay, of the same thing? Looking at the graph, isn't negative infinity this way? So what happens to the y value? Well, it's going to keep going down forever. So if we're given a graph, this is actually very easy for us to look at. But could we do this algebraically? Well, not really, but we can still get this idea. What is 3 times negative infinity? Would you agree that's just a really big negative number? And ooh, you have this really big negative number and you're going to plus 2 to it? Is it still going to be really negative? And so if we can understand that we have this number sense here, what happens to these numbers as I approach infinity, as I go to the left, go to the right, it really helps us understand, would it go to infinity, negative infinity, or will we get stuck to a graph? Okay. And here's again an example of us getting stuck. If I write limit as x approaches infinity of 1 over x, oops, I just typed 1 over x. Well, if I did plug in infinity, 1 over infinity, this idea of 1 over a really big number, what does that huge number do to this 1 as a fraction? It forces you to become 0. And we talked about this before. 1 divided by a very large number, the fraction gives you a smaller number. 1 over 2, 1 over 3, 1 over 5, 1 over 100, 1 over 1,000. Your number is not getting bigger. It's actually getting smaller as we would get closer to 0. Okay, great. Now, Today, your work is really just practicing plugging in limits. What's the limit? As x goes to 5 of x squared plus 3x plus 2. So what happens? What does this graph look like at 5? I don't need to draw a graph. I just need to plug it in. We're not dividing by 0, are we? So it's 25 plus 15 plus 2. 5 times 3 is 15. We end up with 30, 42. That's what the graph looks like. A limit is, what should it look like? Well, it should look like 42 to me. Now, why do we learn all these rules about limits when in this case, it's not going to be a problem? Well, let's go ahead and give you a problem with a problem. If I write the limit as x approaches 5 of 1 over x minus 5, what happens if I try plugging in 5 here? 1 over 5 minus 5 is 1 over 0. And is that possible for us? No, this goes off to infinity. And this is for us going to be no limit. And limits allow me to say, hey, it doesn't look like anything. It's undefined. There's no limit. And more particularly, why does it have a limit? Well, it's not bounded by anything. Now, if I look at the graph, as you approach 1, 2, 3, 4, 5, we have a vertical asymptote. How do I know it's a vertical asymptote? Because we end up dividing by 0. What does the graph look like on the right side and left side? So we're going to break this up into two limits now. Limit as x approaches 5 from the right, and limit as x approaches 5 on the left. So let me go ahead and help you here. Think about how to draw these graphs. We know we have a vertical asymptote where if the bottom exponent is bigger, we're going to get closer to 0, okay? Now, please bear with the way I'm going to do this. It's actually pretty easy, but you have to have some number sense. What's the number on the right side of 5? Here is 5, and I know if I plug in 0, we end up not working. It's like asking your dad a question he doesn't want to answer. What does he do? Totally ignore you. So instead of asking that, what happens when I plug in a number like 5.01? See, do you see how that's on the right side of 5? Well, 5.05 minus 1 is 1 over 5 minus 5.01. Sorry. 5.01 minus 5 is 0.01, right? $5.01 minus $5 is just 1 penny. What is 1 divided by 1 penny? Isn't that a big number? Big positive or negative number, please. Big positive number. So we know it's going to, on the right side, this graph is going to go from 0 and shoot off to infinity. The answer here is infinity for us, okay? What about on the left side? What's the number less than 5? A number less than 5 would be 4.99. 1 over 4.99 minus 5 is 1 over -0.01. Now, 1 divided by -0.01, is that a negative number? See how it's a negative there? So we're actually going to be hinted to go to negative infinity. Stay safe, Judith. Let us know how it goes. So we're able to see which way this graph goes in an algebraic form by just testing what is it like. If it's on the right, I'm going to give it a little bigger number. If it's on the left, I'm going to give it a little smaller number. And then the fraction itself will tell us if it's positive or negative. Okay. All right. Okay, so today your IXL work. You guys are working on IXL. Oops, this is the calculus section. We're going to be working on finding limits right here, number 5, F5. Okay. And what are we going to do? We're just going to plug it in. If I plug in -9, the limit as x approaches -9 of -x minus 3 is -9 minus 3. Now, if you notice when I plugged it in, I don't write limit. No more limits. Once I plug it in, I don't write limits anymore. Is equal to 9 plus 3. is 12. That's 12. What does the graph look like? Oops, sorry. There is no negative there. I don't know why I wrote negative. Sorry. Just -9. Like, oops. That's what it is. I made a mistake. Should copy it better. So it's negative of a negative x, which is a positive 9 and a -3, which gives us the answer 9 minus 3 is 6. This graph should look like 6 there. So all we're doing is plug it in. A limit is, what should it look like? There's no problems here. Okay, let's look at another problem. This we said was 6. All right, well done. Thank you very much. This one, as x approaches 1, I don't think I'm dividing by 0. Just plug it in. This is equal to -3, 1 squared plus 9. -3 plus 9 is 6. Oh, that's a weird answer. They're both 6. But really, a limit is what should it look like? And if there's no problems, if you're not trying to hide anything, it looks like exactly what we hope. Where were you at school? Where were you yesterday at school? Well, let me check your GPS. Well, it's at school. I got nothing to hide. Go ahead and look. And that's the thing about most limits. They are what they are. But if we end up with dividing by 0 or a number that shoots off to infinity, we have special ways of dealing with that too. Okay, so that's all your homework today. And that's it.